Welcome to How to Succeed in ECE Without Really Trying. I'm Dr. Linda DeBrunner, and today we're going to be talking about using superposition in DC circuits. Superposition is a useful concept that we can use in this class. Superposition holds for all linear circuits, which covers all the circuits that we cover. And basically what superposition means is that the sum of the responses is the response to the sum. In practice, what this means is that we can look at the result that we get for any particular independent source and then add them together to the results of the other independent sources in the circuit. So to do this, what we need to do is kill the independent sources so that only one source is active at a particular time. Now, to kill this independent source, all you really need to do is set its value to 0. So this means that for independent voltage sources, and we only do this for independent sources, we're going to short it. That means we set Vs, the source value, to 0. For independent current sources, we're going to set that to 0 as well. And so that means that we're going to actually open that. Okay, so if we have some I source, we set it to 0. So that's going to act like an open circuit. It's easiest to understand superposition by looking at an example. So I've drawn a circuit with two independent sources, an independent current source of 2 amps and an independent voltage source of 6 volts and a couple of resistors. And the question I'm asking is, what is the voltage across the 5 ohm resistor, which I've drawn in the right there. Okay, so the first thing we need to do is kill all but one of the sources. I usually kill the first source I come to, so let's kill the current source. And to kill the current source, we make it equal to 0 amps, right? So that's an open circuit. And just redraw this, and do redraw the circuit. Sometimes students try to save a little time by not drawing the circuit, but it's never a good idea. Okay. And so here's the circuit with the 2 amp current source replaced by an open circuit. That's the same as setting the current to 0. Now, I'm going to give the name of that voltage across the 5 ohm resistor. It's different than the voltage in the first circuit. So instead of calling it V5, I'm going to call it V5 prime. And we just need to solve the circuit for that voltage V5 prime. So let's use loop analysis to solve for V5 prime. So we've got our current I drawn in. We have I times 5 plus I times 7 plus 6 equals 0. So that gives us I times 12 equal minus 6. So I is equal to minus 1/2 amps. Be careful not to lose your signs. Drop your signs, okay? And that means that V5 prime, which is what we were looking for, will be equal to minus I times 5. And I did drop my half there. So don't lose your sign. So minus 1/2 equal minus I, which is minus 1/2, times 5. So that will give us 5/2 volts. So V5 prime is equal to 2.5 volts. Okay, so the sign's canceled. The next thing we need to do is do the same concept, find the corresponding voltage, but this time when we kill that voltage source. So I've redrawn the circuit. We're going to replace the 6 volt voltage source with a 0 volt, which is a short circuit. And now then we need to do analysis to solve for V5 double prime. Again, I'm just adding the primes to make it clear it's not the actual V5 we're looking for. And so we'll use nodal analysis. I think it'll be easiest this time. And that gives us We need to have a ground, which I'll put down here. You could put it anywhere that you want, but it's more convenient that way. And we have how many nodes? We have this big node is ground node, and then we have one more node. So let's give a name to the voltage at the top node, and it's going to be actually the same voltage from here to here, which we've already named as V5 double prime. So doing nodal analysis, summing the currents leaving the V5 double prime node, we end up with -2, because 2 is entering, so -2 is leaving, plus V5 double prime over 5, right? V is equal to IR, so the current I is equal to V over R. And the current leaving through the I7 resistor is going to be V5 double prime divided by 7. And that's so solving for V5 double prime gives us V5 double prime times 1/5 plus 1/7 is equal to 2. I like to leave it as a fraction, so combining we get 7 plus 5 over 35 is equal to 2, which gives me V double prime is equal to 2 times 35 over 12, which is equal to 35.6 volts. Okay, and I could either write that at this point as V5 double prime is equal to 5.83333, keep a good number. But again, there's no reason not to just keep it as a fraction. To get the actual value of V5 prime, we need to add up to get the actual value of V5, we need to add up V5 prime plus V5 double prime. V5 prime was 2.5 volts, which is 5/2 if we care. Let's go ahead and keep it as a fraction, 5/2. V5 double prime was 35/6. So that means that's going to be equal to 15 plus 35 over 6, which is 56, which is equal to 8.333 volts. Okay, and that's how we solve using superposition. Now, if you wanted to solve this using nodal analysis or mesh analysis, you certainly could do that. You would just start off with the original circuit, and if you were using nodal analysis, you'd have 1, 2, 3 nodes, so you'd end up with 2 equations, and you'd have to solve for this voltage and that voltage, so it's actually not so bad, but in some circuits it could be more complicated. If you wanted to do mesh analysis, you'd have this current and this current. Again, that's 2 equations, 2 unknowns, but also you would know what that current was. So it's not too bad either way. I'll leave that as an exercise for you to solve at home. Remember that you can always solve different circuits using different techniques. So if you get a problem that is to use nodal analysis, you could solve the same problem mesh analysis. You could use superposition if you have multiple independent sources. Sometimes students ask me which way is the easiest. Sometimes it's obvious, but usually it's if it's not obvious, just go ahead and start solving. If you get stuck, change to the other method. But usually it's more a matter of what you feel more comfortable with. So while you're learning, I suggest you do it both different ways. So I typically, if I'm solving using nodal analysis, I'll just keep solving using nodal analysis until I, for some reason, change my mind. So usually there's not a big difference. I'm not all about finding the simplest tricks. This is more about learning how things work. If we were trying to solve a very complicated circuit by hand, using all these tricks would be helpful. But if you've got a really big circuit, typically what we do is we use a computer tool to analyze the circuit. So I hope this was helpful talking about superposition. It's often can simplify a problem and make one bigger problem into 2 small problems. So it's a good technique to know.